Okay, good morning, everyone. Okay, hope you have all enjoyed your vacation. ഇനി നമുക്ക് ക്ലാസ്സിലേക്ക് സ്റ്റാർട്ട് ചെയ്യാം. Okay. I think you have gone through the previous problems. This is your question. Okay, take down the question. An effort of 200 Newton is required just to move a certain body up an inclined plane of angle 15 degree. The force acting parallel to the plane. If the angle of inclination of the plane is made 20 degree, the effort required again parallel to the plane is found to be 230 Newton. Find the weight of the body and coefficient of friction. So please notify in the chat box when you have completed the question. So have you finished that? Yes, speed up. After finishing the question, please respond in the chat box. Okay, fine. So what is given the question? Here you can see an effort of 200 Newton. Effort of 200 Newton. That means an applied force of 200 Newton is required just to move a certain body up an inclined plane of angle 15 degree. So you are given an inclined plane at which is inclined at an angle 15 degree. So there a body is kept whose weight is not given, but an applied force of 200 Newton is given to the body just to move. So when this particular body is given the force of 200 Newton, it just move. That means that is the condition for equilibrium. This is the first case. Next, if the angle of inclination of the plane is made 20 degree. So in the another case, the inclination, angle of inclination given is 20 degree. In that case, in order to make the body in equilibrium, we have to apply 230 Newton. So you are given with two cases. In the first case, you have uh, given an inclined plane. If the angle of inclination is 15 degree, then the required force is 200 Newton. And for the second case, the angle of inclination is 20 degree, and in that case, the force required is 230 Newton. Now we have to find the weight of the body W and coefficient of friction mu. Okay, so we'll see how we can solve the problem. So the first case, you can write case 1, case 1, and next case 2. Okay, you can do it in parallel. So case 1, what is given? Effort of 200 Newton is required. There, the angle of inclination is 15 degree. Okay, angle of inclination is 15 degree. So we may draw the figure. (15 degree). That is 15 degree, and the body is kept like this. Okay, and the force required is force required is 200 Newton. Newton. 200 Newton. Next, in the second case, the angle of inclination is 20 degree. So this 20 degree, and the body and in this case the applied force is 230 Newton. So we can mark like this: 230 Newton. 230 Newton. So see this direction. This direction is important. So in order to keep the body in equilibrium, we have to give the applied force in this particular direction. ഇല്ലെങ്കിൽ എന്താ പറ്റുക? താഴേക്ക് ഉരുണ്ടു പോകും അല്ലേ? താഴേക്ക് പോവാതിരിക്കാൻ വേണ്ടി നമ്മൾ കൊടുക്കുന്ന എപ്പോഴും എന്തായിരിക്കും? മുകളിലേക്കായിരിക്കണം ഫോഴ്സ് കൊടുക്കുക. അതുകൊണ്ടാണ് നമ്മൾ ഈ ഒരു ഡയറക്ഷൻ ചൂസ് ചെയ്തിരിക്കുന്നത് രണ്ട് കേസിൽ. സോ ദിസ് ഇസ് ദ ഫസ്റ്റ് കേസ് ആൻഡ് ദിസ് ഇസ് ദ സെക്കൻഡ് കേസ്. Now, so find the weight of the body and coefficient of friction. So you have to find W and mu. So the weight which is acting in this particular direction. In both cases, W is the weight. So you have to find the weight W. So you have to find the weight and also coefficient of friction mu. Okay, so we can see case by case. So in the first case, we can find the free body diagram. we can consider the free body diagram. So how it will come? So we are considering the free body diagram. അപ്പോൾ നമ്മൾ കൺസിഡർ ചെയ്യുന്ന ഒബ്ജക്റ്റ് മൂവ് ചെയ്യുന്നു എന്നാണ് നമ്മൾ എപ്പോഴും പറയേണ്ടത് അല്ലേ. അതിന് ഓപ്പോസിറ്റ് ആയിട്ടായിരിക്കും ഫ്രിക്ഷൻ ആക്ട് ചെയ്യുക. ഒരു സർഫസ്, ഇവിടെ റബ്ബിംഗ് സർഫസ് എവിടെയാണ് ഉള്ളത്? Where is the rubbing surface? This is the rubbing surface. ഇവിടെ ആണെങ്കിൽ this is the rubbing surface. So in that rubbing surfaces or the where there is a relative movement, there will be some friction. ഇവിടെ ഒരു ഫ്രിക്ഷൻ ഉണ്ടാവും. ആ ഫ്രിക്ഷൻ്റെ സ്ഥലത്ത് എന്തായിരിക്കും? There will be a normal force and also frictional force. The frictional force will be in the opposite direction of motion. മോഷൻ്റെ ഓപ്പോസിറ്റ് ഡയറക്ഷനും ആയിരിക്കും. ഓക്കെ, അപ്പോൾ അങ്ങനെ പറയുമ്പോൾ നമ്മൾ പറയുന്നു അറ്റ് ഇക്വിലിബ്രിയം ദ ബോഡി ജസ്റ്റ് മൂവ് ചെയ്യണമെങ്കിൽ എന്തായിരിക്കും? അതായത് ഈ പറഞ്ഞ ഡയറക്ഷനിൽ എന്ന് പറഞ്ഞാൽ എങ്ങോട്ടാണ്? മുകളിലേക്ക് അല്ലേ. ജസ്റ്റ് മുകളിലേക്ക് ബോഡി മൂവ് ചെയ്യുകയാണെങ്കിൽ ഫ്രിക്ഷൻ എങ്ങോട്ടായിരിക്കും? അതിൻ്റെ ഓപ്പോസിറ്റ് ഡയറക്ഷൻ ആയിരിക്കും അല്ലേ. സോ ഫ്രീ ബോഡി ഡയഗ്രം എന്ന് പറയുമ്പോൾ എങ്ങനെയായിരിക്കും? ഫസ്റ്റ് ഓഫ് ഓൾ നമുക്ക് ഇങ്ങനെ നോക്കാം. This is the body and the free body diagram. This is applied force 200 Newton and the weight which is acting, that is W. Now this is inclined at an angle 15 degree, right? 15 degree. Therefore, this is also 15 degree. And here you will have a normal reaction. Which is let it be N1. And the body is moving upwards, so the friction will be in the opposite direction. So direction of friction, this is mu into N1. This is the free body diagram of case 1. So now we can tilt this in order to find the equations easier. So we may consider the x-axis along the inclined plane and y-axis along the normal to the inclined plane. Then we can redraw the figure as like this. In this manner you can redraw it. So the weight will be like this. This is 15 degree. Now the normal N1, frictional force mu N1, Now the applied force 200, that is acting in this particular direction. 200 Newton. Okay, this is the free body diagram. Now using this you can find sigma fx equal to 0 implies you will get one relation. Sigma fy equal to 0 implies another relation you will get. And solving that you will get a particular relation, or you make it as such, that is equation number 1 and 2. From case 2 also equation 3 and 4 you will get, and solving all these 4 you will get the value for W and mu. Okay, so I think you can do this, so please try to do. So this also the case 2 also will explain. After that you have to uh, find the equations for sigma f x equal to 0, sigma f y equal to 0, and solving 1 2 3 and 4 you will get the value for W and mu. Okay, so for case 2, the free body diagram, it will be like this. That is the body. Now the forces, that is the applied force 230 Newton, and the weight W, which is inclined at 20 degree. Now the normal force, let it be N2, and this body is also moving in the upward direction, so the frictional force will be in the opposite direction, which is in this particular direction, and the value of which will be equal to mu into the normal, that is N2. So here also you can tilt the or rotate the full figure, like resolving the forces along x-axis, that is x-axis along, taking x-axis along the inclined plane, and y-axis along the normal to the plane. We can redraw as this is the weight which is at 20 degree, then the other forces 230 Newton, the N2, normal N2, then the frictional force mu into N2, so these are the free body diagrams. So after completing the free body diagrams, you may go to the relations. Okay, sigma f x equal to 0. For the case 1, you can find that is sigma fx equal to 0 implies here. What is sigma fx equal to 0 implies? That is 200 minus mu n1 minus w sine 15 equal to 0 implies mu n1 plus w sine 15 equal to 200. This is equation number 1. Now sigma fy equal to 0 implies n1 minus w cos 15 equal to 0. is equation number 2. Now from case 2, sigma fx equal to 0 implies 230 minus mu n2 minus w sine 20 equal to 0. You can write like this, and on rearranging you can write as mu n2 the similar fashion as w sine 20 equal to 230. That is equation number 3. And now sigma fy equal to 0 implies n2 minus w cos 20 equal to 0. Okay, that is equation number 4. Okay, ഇതുവരെ ഒന്ന് ചെയ്തു നോക്ക്. So is there any doubt regarding solving till now? ഇതുവരെ എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടോ? നമ്മൾ ചെയ്തിട്ടുള്ള ഇതേപോലുള്ള പ്രോബ്ലംസ് പലതും നമ്മൾ ചെയ്തിട്ടുള്ളതാണ് അല്ലേ? അപ്പോൾ ഇതിലെന്തെങ്കിലും ഡൗട്ട് ഉണ്ടോ? ആൽബിൻ തോമസ്, ആൽബിൻ തോമസ്, ആൽബിൻ, ആ ഇതില് ഫിഗർ വരച്ച് ഈ പറഞ്ഞ 4 ഇക്വേഷൻസ് കിട്ടിയോ? ഓക്കെ ഓക്കെ. Now how you can solve for w and mu? We have got 4 relations. In the first relation, it is equating with mu n1 and w. 3 വേരിയബിൾസ് ഉണ്ട് അല്ലേ? w, n1, mu. And the second relation, n1, it is connecting between n1 and w. ഇനി അതേപോലെ തന്നെ സിമിലർ ആയിട്ടുള്ള ഒരു കേസാണ് കേസ് 2 വന്നേക്കുന്നത്. ഇൻ ദ കേസ് 2 there is 3 unknowns, mu, n2 and w, and 4 it is between n2 and w. അപ്പം ഇങ്ങനെയുള്ള ടൈപ്പ് പ്രോബ്ലംസ് ഒക്കെ നമ്മൾ സോൾവ് ചെയ്ത് എങ്ങനെയായിരുന്നു? ഇതുപോലൊരു സിമിലർ പ്രോബ്ലം നമ്മൾ ചെയ്തിട്ടുണ്ട് ഇതിനു മുമ്പ്. അപ്പം ഞാൻ എന്തായാലും നിങ്ങൾക്ക് കുറച്ച് സമയം തരാം. ഞാൻ ഇപ്പം തന്നെ പറഞ്ഞു കഴിഞ്ഞാൽ ശരിയാവില്ല. യു ട്രൈ ടു ഡു ദിസ്. ഓക്കെ, ഒന്ന് ചെയ്തിട്ട് ഇതിൻ്റെ w എത്രയാണ്, mu എത്രയാണെന്നൊന്ന് കണ്ടുപിടിക്കുക. സിമ്പിളാണ്. Okay, I will give you a hint. From equation number 2, you will find the value of n1 and you can substitute in equation number 1. So you will get another equation 5. Similarly, from this equation, that is 4, you have to find n2 and substitute in equation number 3. You will get another relation. And solving those equations, you will easily get the value for w and mu. So we will get these two relations. Now, easily you can see if we divide the same, then w will be gone. So now, after cross multiplying, you will get the final answer. That is WW will be 1. So mu into cos 15 plus sin 15 and 15 divided by mu cos 20 plus sin 20 equal to 200 by 230. So after solving, you will get value for mu equal to, and substituting that value in any of the relations, uh, whether here or here, you will get the value for W also in Newton.
ഇതിന്റെ പ്രശ്നം എന്താണെന്നറിയോ? ഈ ചെക്കൻ കുഴപ്പമൊന്നും.
Okay, so what is the value for mu? Please put in the chat box. Okay, you have to get the value as 0.26. Okay, around 0.26. You'll be getting 0.2593 like that. Okay, so approximately it is 0.26. Okay, and using the value 0.26, you will get the value of W as 392 392.18 around this value. Okay, so you try to solve the same, and you will get these values: mu as 0.26 and w as 392.1878. Okay, so we will continue in the next class. Okay, next session is after the lunch break. I think it is 1:10, right? I think yeah, at 1:10. So I'll take the attendance now. AK Google.
Present.